is a bit of a complicated talk to give because for many of you, this will be my only chance probably to talk to you ever, so I won't tell you more or less the story of my life. But there are some people who are kind enough to show up here, and that's a bit embarrassing because they've heard it so many times. So I designed sort of a compromise. I'll start with one thing which is sort of the general theme or the general message I try to convey. And this is not necessarily very original, and much of this has been a result of many years of joint work with David Schmeidler, who used to be my advisor, and we worked together for some 40 years until he passed away last year. These things appeared in various publications, mostly joint publications. Many of these things were discussed also in joint papers with other colleagues such as Andy Postlethwaite and Larry Samuelson. What I want to do at the end is to talk about some things, a new paper, and this is with Stefania Minardi and Fan Wang, so I have only my name here because I guess maybe for 1 hour it will be just general stuff and not necessarily my name. I'm just giving the talk about general ideas, and then I'll try to present some new paper with Stefania and Fan. The main message I'm trying to convey is that I don't belong in this conference because this is about cognitive limitations, and what I'm going to talk about is the issue of Bayesianism, whether we can quantify uncertainty in a probabilistic way. And what I'll try to convince you, at least, most of the talk is actually about trying to convince you that it's not about bounded rationality. It's not about bounded cognitive abilities. And actually, it's more rational to sometimes not to be Bayesian than to be Bayesian. And in order to explain this, I need to define some terms, and there'll be a bit of digressions. Warn you ahead of time that I'll be going a little bit in circles, but I have an idea of where I'm going. So, and even when I digress, mostly these things are on the slide, so these are planned digressions. So the question I want to start out with is, does rationality imply Bayesianism? And rationality, we probably have our own personal definitions. I'll try to go back to it in a second. Bayesianism, I'll discuss it in more detail, but in a nutshell, it's the idea that we could quantify any uncertainty in a probabilistic way. And most theorists would say yes by definition, and then I can just pack my stuff and go home. The message I'm trying to convey, and again, it's a bunch of people who believe in this, I believe, is that this is not necessarily the case. So I need to define the concepts for that. And I'll try to convince you that this might be relevant. Okay, so some of the discussions would be a little bit on the philosophical side, which I hope you'd find, and some of it I think is actually quite exciting because the history of it is also, the philosophy of thinking about it is a very exciting history. But I'll try also to convince you that it's not just a matter of philosophical discussions, and some of it is actually quite practical. So let me start with what is rationality and how we use it. So in previous centuries, and when you see someone like me say previous centuries, I mean before the 20th. Okay, so I don't mean, I know that you guys have your own century now, but I really mean really previous centuries. So people had this, philosophers had the idea of what rationality means, and philosophers did not shy away from saying, what rational man, not person, should do. But things change. So in a sense, at least in economic theory, since the beginning of the 20th century, it sort of took a step back and saying, rationality is a matter of consistency. So if you're coherent enough in your decisions so that I can think of you as utility maximizer, then that's fine. You could fit into our textbook. So if you satisfy something like completeness and transitivity, that's good enough. I'm not going to tell you what should get into your utility function. So I feel like it's a step back from saying what rationality is. It's more about form than about content. You could see this as a bit of a postmodern move to say that we are not going to tell you what is rationality, but rather you could have your own rationality as long as you're sufficiently coherent to fit into the model that we have. what I'm trying to suggest is that maybe it's time to take yet another step back and to say that even which coherence notions we think of as rational is also a matter of taste or open to debate or something subjective. So the first time this sort of occurred to me was a long time ago. It was when, 1990. I was at a conference, and Peter Fishburne was giving a talk there, and Peter Fishburne was writing most of the textbooks when I was a student, apart from Lucien Rafer from '57. All the textbooks were by Peter Fishburne. So he was a very well-established guy. And he was giving a talk about preferences that were cyclical, that violated transitivity in the strict sense, and obeyed some other axioms, by linearity or something. And there was a question in the audience of violating transitivity, or in particular maybe satisfying independence but violating transitivity. And it seemed like violating some notion of monotonicity that we have in our minds. Peter Fishburne responded by saying there's nothing irrational about cyclical preferences. And I walked away trying to think what does he mean exactly by that. So I'm taking here a sort of descriptive approach to the sociology of science. So people are using the term rationality, and what do they mean by this? And I think the best definition that I could come up with is to say something is rational for a person if they feel okay with this. So that if I expose them to the analysis of their own decisions, they don't want to change their mind or something. Actually, I had a very poor term for this. I thought about being ashamed, but at the time Amos Tversky suggested to me being embarrassed is a much better term. Yes, I'm adopting Amos Tversky's term. The question is, can I embarrass you by showing you which decisions you made? And of course, no new information is allowed. Okay, if you bought a stock and now I tell you that it went down and you feel bad about it, that's not fair. I'm talking about just pure analysis, the kind of thing that you could have maybe figured out on your own. So it means that rationality is a form of robustness, of whether your decisions are robust to the analysis that I, as a theorist, can come and try to show you, but you are the ultimate judge of what is rational, what is not rational for you. And it looks like a terrible, terrible definition as compared to the one we have. Okay, the definition we have is to say, here are some axioms that I wrote on the whiteboard, and this is rationality, and that's it. And it has, the weaknesses of my definition are multiple. First, it's subjective. So something that might be rational for one person might not be rational for another person, and then I might have to split it in different societies, maybe levels of education. Everything is very messy now. How do I measure embarrassment? Whether you want to change your mind or not. The whole thing becomes very messy, lacking the actual practicable measures that I cannot offer you practical measures for this. I'm just suggesting the idea. And it's going to be an empirical questions, and theorists don't like this. Theorists would prefer to write down on the blackboard, here's wiggle that satisfies these axioms, and that's rationality, not to go out and start testing who's rational, how many of the college graduates are rational. It's a mess. The other thing that sort of might be a weakness of this, and this is something I found sort of the hard way at some point, is that it's not necessarily monotonic in intelligence. Okay? And what I mean by this is that two decision makers can make the same decision, which we consider to be a mistake, and then we try to show to them that this was a mistake. So this happened to me in class, actually, from Amon-Borch's independence axiom. So I got students to violate the axiom, and I think that's the best way to explain it, and then say, wow, you see, this is what you should have done, and you've done this. But the problem is that if they don't understand, then they're not embarrassed. Okay? So if you have two decision makers, one who's very intelligent and understands the argument, and then they can feel embarrassed, and the other one who's not so intelligent might just stare at you and say, so what? And that's not exactly in line with what we have, because we tend to think of rationality as something that has to do with wisdom and intelligence. I actually like this feature. Okay, so I'd like to tell you this is a feature, not a bug, that this is a strength as a definition, not a weakness. Because I don't think that the role of decision theorists is to tell people how they should make decisions. I don't think that we are any gurus or spiritual leaders or religious leaders. We are here, I think, to help people do what's better what's best for them in their own eyes, what's best for societies in their own eyes. So I like the idea that we're not standing there and I take a sword and I'm telling Elchanan, I hereby dub you rational. That's not my role. Okay, my role is maybe to talk to him and see, and if I get him to change his mind, then okay. If not, it's not. And in particular, suppose that I can tell Elchanan, you're not being rational because you didn't play chess optimally. And last time, you played against Kasparov, you lost. Okay, so I'm sure no one likes to lose, but the question is, will he change his behavior next time? And if the answer is no, because we don't have an algorithm to play this chess optimally, or if I'm talking about some NP-complete problem that I cannot tell you how to do better, then okay, I can call you rational until I'm blue in the face, and I can tell you all kind of other bad things about your character, and etc. But it's not going to change anything. Right? I mean, next time you're going to see some same kind of problem. You're going to do the same kind of mistakes or whatever. So for me, I don't think it helps very much to call this irrational. If you want to call it irrational, okay, you could tell me I'm an idiot. Fine, let's move on. It's not going to change my behavior. Now, why is this, maybe I should start by asking who cares, right? Because we can define things any way we like, and some nice quotes are from Lewis Carroll and Dodgson, Humpty Dumpty, where at some point he tells Alice, my words mean exactly what I want them to mean. When I want a word to mean a lot, I pay it extra. So really, there's no point in arguing about definitions. Definitions are just a matter of usefulness. The reason I think that this definition is sort of useful is that we are for a couple of decades, I guess, we are in a very interesting time in terms of decision theory or decision science. On the one hand, we have this wonderful structure that I would call this rational choice. I wouldn't call it theory because it's not exactly theory. There's something that we call maybe a conceptual framework. It's not a concrete theory, but the whole idea of construction of game theory and decision theory and macroeconomic and constraint optimization, I think it's a very beautiful fundamental structure to think about the world. I think it's one of the great intellectual achievements of the 20th century. I would put it on par with Chomsky's linguistics. I think it's wonderful. And I'm not calling it a theory because I think it's there's still a mapping between the theoretical concepts to real-life objects that allows you for a lot of freedom, maybe a little bit like evolution. So it's not necessarily a theory in a Popperian sense without some auxiliary mappings, but it's certainly a way of thinking that is, I think, extremely powerful. On the other hand, there are findings from psychology. So the most famous, of course, are Kahneman and Tversky. But there have been things before, and there are a lot of things after, and one by one, we see violations of everything. And as Amos used to say, show me the axiom, I'll design the experiment that violates it. So we know that nothing works. And the question is what to do if we still are in the business of social science, because there is the option, and for many of you it's not too late to think about, it's a mess, let's do something interesting or that works, at least. This is interesting, but doesn't work. So then the question is, what do we do when we have this conflict between theory and reality? And there are basically two approaches. One is to do what normal science do, because, normal, not necessarily natural sciences maybe, and this is to refine the theory in a Popperian sense. Okay? You say it doesn't work this way, so we have to elaborate and say when it does work and to what extent, and which is to a large extent the direction of behavioral economics, to say let's improve the theory and make it more accurate with these new insights. The other things that we can do in the social sciences, but that physicists they cannot do, is that we could try to sell our theory. We try to explain to people how to make decisions differently. Okay? So if we know from actually anyone who ever taught probability noticed that people confuse probability of A given B with B given A. Okay? And Kahneman and Tversky, of course, ran this in experiments and called it ignoring the base rate, etc. We could use it. Okay. Actually, someone told me that in France one day they had an ad for the national lottery that says that 100% of the people who won the lottery bought the ticket. So yes, we could use it. It's pretty applied. But we could also go out and teach it. We could go and you know, teach people how to reason. And actually, we've had I mean, I've been using this example for many years, but in the past 3 or 4 years, we had an example of this because with COVID-19, many people had to deal with conditional probabilities, and you saw some of it being taught even in the press. That you know, you have to think about the base rate when you think about the percentage of vaccinated people at hospitals, take into account that there are more vaccinated than non-vaccinated and stuff like that. And I believe we should teach this in high school. I think this is some of the basic things that we should get the conditional probabilities, control-set paradox. So, you know, one approach is to say, okay, people make mistakes, but we could change this because we could use our theory normatively. And if I ask myself, what is the watershed? How do I decide whether I'm trying to bring reality closer to theory along the lines of behavioral economics, or theory closer to reality along the lines of behavioral economics, or vice versa, namely changing reality according to theory by preaching our theory, then I think that this test of rationality is not a bad test. So if I'm telling you you should play chess optimally, but there's no way I can teach you how to do this, then there's no point in using it as a normative theory. And actually Reinhard Zelten used to say that normative theory that tells you you should run 100 meters in 4 seconds is not very useful. So yes, this could be my normative theory, but it's not going to change anything, not going to make the world a better place. If, however, it's something that I can convince people of, then maybe I will make the world a better place, and this is why I think this is sort of a useful definition. So this is, let's say, the first definition. I'll try to refine it a little bit. The refinement of definition of rationality, which made its way, I mean, this is later in the textbook and a paper with David, Massimo Marinacci, and Fabio Maccheroni, is the distinction between objectivity and subjectivity. So let me start maybe with these terms in general. At some point, Anscombe Bauman has this nice axiomatization of subjective expected utility, which is sort of came after Savage, but sort of. I mean, I won't get into this, but it's a very nice axiomatization, trying to also to make a conceptual point that subjective probabilities are derived from objective ones. And at some point, they deal with, so there are objective probabilities that are given in the model and subjective probabilities that are derived from your preferences. And at some point, they say, what is subjective probability, or what is objective, I'm sorry, and they say, well, everything is subjective. When all the subjective happen to coincide, we call them objective. So just thinking of the term objective as a nickname for this particular case where the subjective terms happen to coincide appealed to me very much, and I thought this was beautiful. And at some point, David and I were writing a book, and we got to define general terms because, you know, in the book you could afford to do things that referees don't let you to do in the paper. And I wanted to quote this definition, and David didn't like it, and he said, well, suppose that the two of us are here and trying to ask, you know, what is the length of this room? It would be the length. Let's say this is the length. And let's say that both of us say it's 10 meters. And there's another scenario in which both of us are here and say that it's 10 meters, but there's also a meter that's stretched out, and we actually see that 10 meters is what the length that's written there. It feels different. In both cases, we have subjective estimates that are the same, but it feels different. Now, when I'm trying to think about why it feels different, and I agree, the reason is that in the latter case, I believe that should you now take someone from outside the room and get them in and ask them, they would also agree with the same thing. Okay? So it's about my, if you like, second order, I call it second order subjectivity, because it's my subjective beliefs about what people in society would say. And we could even make it very practical in the sense that if there are only two of us in the room and we both tend to say it's 10 meters, and now we say, okay, I'm going to sample people, somehow incentivize them to give me their estimates. Let's bet, of the 10 people, let's bet on the standard deviation of their estimate. And if there is no meter here, I would tend to bet that they're not going to be exactly, all of them exactly the same 10. And if there are only 10 people and there is a meter, I'm willing to bet on sigma being 0. Okay? Because 10 people, I think, take the risk that they'll just, none of them would be so silly as not to look at the meter. So objectivity to me is second order subjectivity, but it involves other people in society. And again, it's going to be a very messy concept because who are these people? What do I know about them? I mean, how old are they? Can they read and things like this? So of course things would be very messy. But that's the way I'd like to think about objectivity. And in this paper with Massimo and Fabio, we talked about these two notions of rationality, which are somewhat related in a sense to Habermas' notion of communicative rationality, but he builds a lot more democratic values into the definition. And I have nothing against democratic values, but I think this is a separate issue. So I'm trying to define rationality in a way that would work also in countries we don't want to mention. So what is the objective and subjective definitions of rationality would say that now for a decision maker I would have not one observed relation but two. One of them that we denote by the star is the one that is sort of the objective one. And I'd like to think of it as saying, I can convince any reasonable decision maker that this is better than that. Okay, so if you have two options, A and B, and I can, maybe I can convince you that you shouldn't smoke, but at least I can convince you that smoking is detrimental to your health. We know that this has not been quite established with RCTs, etc., but I think most people would agree that this is the case. So this is, again, any reasonable decision maker. It's a very messy idea. Who are the people? What society do I have in mind, etc. It's a mess. But that's, if I think about something practical, I have to think about this mess, if not actually do something about it. The other one, the weak definition, is the subjective one. Says, well, maybe I cannot convince you that this is right, but you cannot convince me that I'm wrong. Okay? So it's both of them are about rhetorical uses, and like, can I convince someone else with all the mess of who are the people? But one is sort of on the offensive, one is on the.
Sorry, just as a curiosity more, but like, I mean, this definition doesn't it record some like notion of modality, modal logic, like possibility and necessity or something like that?
Right. Yes, it could, and to be actually honest, a bit more honest, but it's not exactly, they're not exactly the same kind of creature in the following sense. This thing would apply to particular instances, so I can convince you that A is a better act to take than B. This, I need your entire relation to. Okay, so mostly I would think about whether it's consistent. So let me give an example of an axiom which I think both should satisfy to me. It's a subjective question, but I think transitivity makes a lot of sense for both. But it is read very differently in both cases. So in the subjective one, I would say, look, if you're being cyclical, then you're going to look bad. Okay, so if you are the mayor and you're going to make a decision, and yesterday you chose A over B, and then B over C, and now you're going to choose C over A, I tell you, tomorrow there are going to be headlines you're not going to like, because you're going to look foolish. I don't know whether A is better than B or not. I'm just telling you that this cycle is what might make you look foolish. Okay? So this is closer to the previous definition. Here, if I say A is better than B, I'm saying, look, there is some evidence, scientific, statistical evidence that says that A is a better choice than B. So it's really a property of the instance. And then I would use an axiom such as transitivity and many of the other axioms that we have as sort of, if you like, an axiom schema or something. It says, if you have A is better than B, so supposedly you have proof, so to speak, involving data, statistics, whatever, that A is better than B. And there is another one that B is better than C. Now I generate a proof that A is better than C using transitivity. So I use transitivity as if you like, an axiom schema or something. In that, if we take this approach, then it stands to reason that this relation is going to be incomplete. Okay, so we start out with knowing very little, and we're trying to build our way up, and science is going to be silent on many issues, so we can't expect to have a concrete answer for each and everything. This one, by contrast, what you actually do, I'd like to be complete. Okay? So actually, when these things came together, I'll mention shortly the statistical issues. To me, it was a bit closing of a circle, because in my master's with David, I had an incomplete relation with multiple priors and something along similar to what Bewley's model. So it seems natural that you have something incomplete, but then if you don't tell me what's going on, then your model is somewhat wrong. I mean, so you can have an incomplete preference, and then God knows what's going to happen. Okay, so I can suppose you're giving advice to some politicians, and the relation is incomplete, and you pack your suitcase and you leave, and then who knows what they're going to do in your absence, right? I'd like to see this in a model. Okay, so this is why the standard, I mean, complete, I mean, is any two things can be compared, right? So the standard justification of completeness is necessity. If something is going to be done, so let's see it, bring it forth so they can see it in the model. But then we can do both. So in some sense, it'll be natural to say, okay, let's see here what is actually done, and this would subject to subjective rationality. Maybe at least let's not do something terribly embarrassing. This thing is what science, statistics, etc. have established, and that I can live with incompleteness there. And then there are other axioms, and I won't get into the details right now, but there are other axioms where you can say, well, if I think of this as what has been proven, I can assume much stronger axioms here. So for instance, if I take, the full strength of independence of Anscombe-Bauman model, I can say, if it has been proven that A is better than B, then here is now a proof that this and this is better than that and that. By contrast, if you just made some decisions because you shrugged your shoulders and you had to make a decision, that's not a very, very, very stable foundation on which I can build up other preferences, and maybe you're going to satisfy all the weaker axioms. Okay? So while I gave this example of transitivity, which I believe that both of them should satisfy, there are other axioms where I would say, okay, if it's a stronger axiom that the incomplete one should satisfy, not necessarily the complete. Okay. And along these lines, okay, I should say something about before I talk about statistics, just to make sure what we talk about in terms of Bayesian approach. I'll talk about its history a little bit, but basically what I refer to as Bayesian is to say formulate a state space which is going to be informative enough so that if I know the state, I know anything that I should know. So this is what all uncertainty is resolved by a state. So anything that might ever matter to us should be written down in the state. Then we have a probability on this, a prior probability, and we update by baseline. And the reason maybe to have this slide is to say that expected utility is not necessarily here, because many people who are Bayesian in statistics and computer science are not about decisions at all. Okay? But this is, I think, the common thing when people talk about the Bayesian approach, even though in Bayesian statistics, in a second I'll talk about it, it's a bit weaker than this. To us, it usually comes with the expected utility maximization, because that's sort of the justification. The derivations we got of the Bayesian approach come part and parcel with the expected utility maximization. A short digression about the relationship between classical and Bayesian statistics, and I think they sort of roughly correspond to objective and subjective rationality. So this is something that's been bothering me actually from teaching very basic classical statistics classes, when at some point you might say that confidence intervals is not probability, and you could trick students to make mistakes. And there are some nice examples that Bayesian statisticians developed in the 1930s to show how silly the notion of confidence could be. So again, it's something that's like a probability of A given B and B given A. It's something you would put on exams, because otherwise, asking people to take the square root of n, then you could see if they got the notion that confidence is not probability. But then the question is at some point of why would they care? Okay? And why would they care that about the confidence is not probability, significance level is not probability, etc. And I think that there is a reason, and this is that the mindset of classical statistics is very much about objectivity. It's very much about what can be proven. And the Bayesian one is much more about subjectivity. Okay? So in classes, I give this example. This is something, by the way, that existed in stats classes when I was a student in stat textbook, and somehow disappeared, and I'm not sure why. And I'm actually trying to talk to legal experts to understand why. Because to me, it was really a beautiful example to understand as a student the difference between the null hypothesis and the alternative. And once you put it this way and you say, look, there is a default out there, and you're trying to prove H1, and by making H0 look ridiculous. But if you didn't manage to make H not look ridiculous, doesn't mean that it's true, okay? It's just, so being acquitted doesn't mean that you're really innocent. And to me, it made sense very nicely. Now, if we go to this example in the Bayesian approach, I should have a probability of the two hypotheses. And let's say, that I'm the defendant and the judge there is my mom, and my mom thinks that my son could not have done it, the prior probability is 0. And you show her a bunch of, evidence and DNA tests and everything, but my mom can't be convinced because 0 remains 0 under Bayesian updating, and it's wonderful. But maybe it's not my mom. Maybe it's someone who, as I walk in, doesn't like my face and says, this guy looks suspicious to me, and with a little bit of evidence, I find myself in jail. I don't really want to live in this society. I want to live in a society where there is something like a claim to objectivity. Now, we can never get to objectivity. Objectivity is not a place, it's a direction, but we could try to be more objective. Okay, so we were sufficiently mature and we've read some postmodern analysis not to believe that there is something like perfect objectivity, but it doesn't mean we shouldn't try. Okay? General problem that I have sometimes. Sorry.
Just a small comment. Couldn't you do a Bayesian alternative to the hypothesis testing by having the judge instruct the jurors that they should attach a prior of 1 minus epsilon to innocence, and then the jurors update?
Right, sort of. So there is this thing, and this is done by Jeffrey in the 30s, and I think in many things it's more supposed to be a little bit more like the uniform, and there is you take the maximum likelihood here and there, and you ask, and again, there's going to be some social norm, just like we have a social norm for what is the alpha, there is a social norm for what is the overwhelming principle. But what I want to say is I think that these are two methods that are for different goals, okay? So if you go back to the 30s and the 40s, so I am talking about the previous century, of course, you see that there was really religious wars over these two things. And today, much less Bayesian. We see a lot more Bayesian statistics in the past 20, 30 years. But I do think that in principle, these are different things. Okay? So one thing, the way I think about classical statistics is to say, we live in a society where people have different beliefs. And they might have incentives to pretend that they have different beliefs, like my mom, okay? And we still need to make decisions. So we ask, when can we say that society has proven that, while we know that there are different beliefs and I don't want a certain prior because people have different beliefs, whether it's about smoking or climate change or whatever. So we aspire to objectivity, and to the extent we can, we try to take subjective probabilities out. There are then the tools for how to make decisions for a given individual, and then we do want to allow subjectivity. So I can often, I give an example of myself sitting, as a juror and looking at a certain case and saying, okay, I have to acquit this person. And next thing I know, turns out that my daughter wants to date this person, and I tell her, no, honey, you're not dating this person, you're staying home. Because it's absolutely fine as a father, let's say for myself, okay, to use my subjective prior. Okay. When I am a juror, I'm supposed to try to ignore it. Okay, so I think these are different goals in our story. And in a sense, they correspond to objective and subjective rationality. So objective rationality is what can be proven as the thing that, I know that people have different beliefs and different goals and etc. But what can we still say is sort of beyond reasonable doubt, whether the Bayesian one is what's best for you. And I think it helps to explain why the undergrad economics that we teach looks a little bit schizophrenic, because we teach our students how to do empirical work using mostly classical statistics. I think still most places would still do hypothesis testing and significance test on the betas. But the agents in our models are Bayesian. Right? So why are the agents, the supposedly rational agents in our models are Bayesian, and we are doing empirical research using classical statistics? The answer is these are different things. Because when I do research, I'm trying to convince a community of scientists, and I'm trying to show that this is beyond my hunch. It's not because I took a certain subjective probability and it works, but I'm aspiring to objectivity. Importantly, both of these methods are not perfect. Okay, so the classical statistics, of course, cannot attain perfect objectivity. We know that, and we know how to play with statistics, and there are books written about how to do these things. And what I'll try to convince you is that the Bayesian one is also not perfect for our intuition always. Okay? That, supposedly it's trying to capture intuition and can allow for gut feelings, etc., but that it's not always perfect. Okay, so a little bit on the history of these things, which I'll try not to talk too much about because it's really very, very exciting. So I think the Bayesian approach in some sense begins with Pascal's wager. So Pascal is almost the first to define probabilities. There was Huygens around the same time. There was Cardano about 100 years before. But Pascal gets a lot of credit for inventing probabilities. And that's in the context of risk of playing card games. What happens if you're gambling on a game and the game is over? I mean, it's not over, but you have to terminate it before the game is over. And the question is, what's the right way, the just way to divide the gamble? And this is where he came up with the notion of expectation. Interestingly, there's evidence that the same kind of problem exists in the Roman times, and there are a few books written about why probability theory has waited so long and hasn't been developed until the 17th century. So there are different nuances here, but I can say that in general, it seems to me that the agreement is that until the Renaissance, people used to negotiate the future through some deities. Okay, so in biblical times, you would sacrifice an animal if you go out to battle, and later on you would pray, and you would fast, and do things like this. So throughout the Middle Ages, at least in Europe, the negotiation and dealing with the future was done with, somehow dealing with God one way or another. The Renaissance is a period that puts humans at the center, is considered to be a point where also dealing with the future had to do with that. Pascal's wager is fantastically beautiful. There are about 5 ideas of, the basic argument, I guess everyone heard some version of, which says you're trying to decide whether to believe in God or not. And he spent some words to say that, could you become a believer? I mean, it's not like, you just choose what to believe. That doesn't sound very rational. But he's explaining that if you run a certain lifestyle and, pray all day, etc., and his older sister joined the monastery, so you could become a believer when it matters. So you have to make this decision of whether to become a believer. And either God exists or not, so there are like states of the world. And he's describing in words a decision matrix, okay, so which is, I think, also a first. And he starts by an argument of dominance, saying if God doesn't exist, so what did you lose? But if God exists, you have the afterlife. And then he moves on, so after describing dominant strategies, saying, well, should you say that you are going to lose something in this world in order to become a believer, then he says, whatever awaits you here on earth is finite, and the afterlife is infinite, and therefore you should bet at all odds. So he doesn't say the word subjective probability or expectation, but given the fact that he invented the notion of expectation, he's basically telling us if you put even an epsilon probability on God existing, epsilon times infinity, it takes over. In many cases, the popular version I heard, and unfortunately also put in one of my textbook, and what I find on Wikipedia, has to do with burning in hell, in case you're not a believer. But it's not in Pascal's writing. So in class, I even say that he also invented positive marketing, because he's not mentioning what's going to happen to you if you're not a believer and God exists. And then he goes on to say, and should you don't know what the probability of God is, then you have a range of probabilities, but the previous argument works for each one of those, so therefore you should still believe in God. And by the way, he also gets a lot of credit for changing the question from whether God exists to whether you should believe in God. And I know that in proper English I should say whether God existed, but I don't want to get into trouble, so I'm allowing the present for that. Because before him and after him, certainly in medieval times, but also Descartes, cogito ergo sum, is about 20 years earlier, Leibniz later on. The national sport for philosophers was to prove that God exists out of nothing. And he, though he was a very devout believer at this point, he's not trying to prove that God exists, but that you should believe in God. So it's, again, putting humans at the center. And there's a whole book written about, how modern he was in this sense. Along the way, there is this probability that God exists, okay? This epsilon, that God exists. And that could only be subjective probability, okay? It's not the kind of relative frequencies that we have. And in a sense, I think that he was here the real pioneer of saying, let's use the structure of probability that we constructed for relative frequencies and games of chance. Let's use it to somehow put some discipline on our thinking and our beliefs, okay? Which is often the way I teach subjective probability. I take something like Kahneman Tversky's Linda's example, the bank teller, where many people give a subset, consider it to be more likely than superset, and say, I'm not going to tell you what probabilities to use, but if you use subjective probabilities, this kind of mistake would never happen to you. Okay, so this is, in a sense, what he's doing very early on. Okay, we'll skip these. This is expected utility with Jacques Bernoulli with the law of large numbers, and his two nephews with the expected utility under risk. So it's not terribly relevant what I want to say. Where's Bayes? Okay, maybe I mentioned Bayes some other place. Anyway, 1763, again, posthumous is Bayes' writing, and Bayes comes with the argument, according to McGrain, okay, and this is relying on her book, in order to, what else, prove that God exists, okay? And Bayes' argument is to say, it's basically what's known today as the intelligent design argument, or known for, I guess, decades in the philosophical literature as the watchmaker argument. So the watchmaker argument, you walk by the beach and you see a watch and you could say, well, maybe coincidence, wind, sun, whatever, glasses, cogwheels, it could happen, right? Or there was a watchmaker that designed it, right? So what do you find more likely? And that's basically the intelligent design argument, and this is what Bayes uses. And so Bayes says, if God exists, then, and let's say that's God of the scriptures, then we have the world created in 6 days, etc., with all the complexity, the amazing human mind and the DNA, which Bayes didn't know about now, but we know, okay, so all these amazing things that we see in the world with probability 1, because this is what God willed. If God doesn't exist, okay, you could start all kinds of stories. Again, evolution came later, but we could start telling stories about mutations and this and maybe it. Okay. Which is more likely? Now, Bayes was sufficiently sophisticated to know that the probability of A given B is not the same as B given A. So if the probability of the world given God is 1, that doesn't mean the probability of God given the world is 1, or even high. He needed a prior. And he used the 50-50 prior and went on. Okay? So he just... But this is the commitment to the prior. You don't know something, but you put your probability, some probability, subjective probability on that. And by the way, it's nice also because I think this is intuitively, way before people talked about probabilities, this is also the notion of a biblical miracle. Okay? Because if you think about a miracle, how do I prove to you that God exists? I'm going to walk on water, right? So given the fact that I managed to walk on water, then you think, well, it's more likely that God is there and God allowed me to walk on water than I just developed this ability. But I need something quite exceptional, because if we were doing maximum likelihood to judge whether God exists or not, I wouldn't need something so exceptional. In order to convince you that God really exists, I need to go beyond maximum likelihood, and the Bayesian one is the simplest model that explains this. Okay? So I do something extreme, like I turn snakes into canes, canes into snakes. I walk on water. I do something that otherwise would have had a very low probability. Okay. Ramsey and Definetti believed in this approach, and they thought this was the only rational one, and they, and by the way also Borel in one line, suggest the idea of deriving probabilities, subjective probabilities from behavior. And this is along the lines of logical positivism that was gaining ground, and the general revealed preference approach that made its way into economics in the 20s and 30s. There were people who didn't like it, like Frank Knight and Keynes, who didn't believe that any uncertainty could be quantified. So there were some debates. I think generally speaking, Ramsey and Definetti were very brilliant mathematicians. There is a point where Keynes sort of admits that Ramsey convinced him. David later told me that actually this was in the eulogy, and this was when Ramsey died very young, so it's not clear that maybe Keynes was just being nice. In any event, because in 37 Keynes writes somewhere that we cannot quantify probabilities. Anyway, the debate was sort of open until we got to Savage. Okay? And Savage in 54 published this fantastic theorem that is basically convinced the entire field that the only way to be rational is to behave according to Bayesianism, namely to behave as if you have a subjective probability. So I guess you know what axiomatizations are, okay? So not spend time on this. I'll just mention that generally I tend to think of these as rhetorical results. I mean, in this sense, these axiomatizations are not about economics, but about part of a discussion of economists of which model to use. So it's, and this was, by the way, for Neumann Morgenstern, we also have beautiful examples that Ivan Moscati dug up some letters about the expected utility approach, where Savage was actually convincing the luminaries of the day, including Paul Samuelson, that expected utility theory is not just a case of convex preferences. I mean, if you put expected utility, because this is the way Samuelson thought about it. And using the axioms, he actually convinced Marshak and others that, and Samuelson, that this is the right model to use. And that's basically what Savage did to the profession with his axioms. Okay, so he basically convinced us that the right model to use is expected utility relative to some subjective probability. I'm not going to go over these. I'm just going to say this is extremely beautiful. When X is finite, 6 axioms suffice. So we have a weak order. We have basically 3 axioms of coherence, which are very simple to, I mean, the notation might look messy, but let me tell you what you don't see here. You don't see a plus, you don't see multiplication. Okay? There's no math in this. So as opposed to for Neumann Morgenstern, that assume that I know what probabilities are and I can define the independence axiom. Before them, Definetti with subjective probability assume that you know what the payoffs are and you could do addition. There's no mathematics here. Okay? No linear structure, no measurable structure, no word on topology, absolutely nothing. Like really, in the work, it's, with your bare hands, you have to start working on this. So these are axioms that are very compelling. This is the famous sure thing principle, some form of monotonicity and some form of separation of taste from beliefs. P4 I want to get for free. P4 only says that you care about something. Okay, P5, I'm sorry. The non-triviality assumption just rules out the case that I'm already dead and I don't care about anything. I'm completely indifferent. Of course, if I'm completely indifferent, I am an expected utility maximizer. But the problem is that you won't be able to look at my behavior and infer my probability in a unique way. Okay? So this is why Savage spends a whole axiom on this, just to say, let's rule out this trivial case, which is not a problem with the theorem, only with the uniqueness of the probability. Okay? And P6 is sort of a technical axiom, which is actually quite sophisticated. It has a little bit of continuity there, a little bit of Archimedeanity there, but still, 6 axioms, and this is what you get. And I don't know of any prettier theorem in the social sciences. I think it's fantastically beautiful. Okay? And you get both the utility and the probability from these things, and the set of outcomes is completely abstract, the set of states is completely abstract. And again, I didn't say anything topological. I didn't say anything measurable. I didn't say anything that bees cannot understand. I'm just giving this example because Avi Schmid used to run these experiments on whether bees satisfy Savage's axiom. So this basically convinced the entire field that the only rational way to make decisions is to maximize expected utility relative to some probability. So I'll call this your subjective probability. And yet, so there are some problems with this, okay, despite the beauty of the theory. The first one I would say is that if it's so rational, why isn't it objective? So suppose that Mike and I are having a debate, and I say that probability that the war will end is within a month and is 0.4, and he says it's 0.6, and we're arguing, And, you know, I cannot convince him, and he cannot convince me, and we walk away. And on my way back, I think I should ask myself, why couldn't I convince him the probability is 0.4? I mean, I know it's subjective and everything, and Savage told me subjective, and Definetti and everyone, and okay, but he's a smart guy. I mean, if I can convince this smart guy, maybe I should give some, you know, leeway and allow for the possibility that maybe he's right and I'm not. Okay, so this is one thing that would sort of nag me about my subjective probability that I'm so adamant about. The second one, again, I'm sorry if you've heard this 15 times, some of you have. Let's say you walk down your campus and you see there's going to be a talk this afternoon about arborites and cyclophines, and I made up these words. I think actually one of them, I think, embarrassingly does exist. But let's say that you never heard these terms before. And you know there's going to be a talk about it, but you have no idea what field of knowledge they come from. Maybe you know arborites and cyclophines are types of abelian groups in math, or maybe they are enzymes, or maybe they are ancient languages. Okay? You just know that there is a talk about them, and I ask you, what is the probability that all the arborites are cyclophines, that arborites is a subset of cyclophines? Now, if you're terribly rational, you should give me a point probability on this. Your subjective probability is that all arborites are cyclophines. Okay? In the afternoon, we'll figure it out. Okay? And I think for most of us, the answer is, look, I don't know. How could I estimate it? And so I tried it on some colleagues. And then the question is, someone says, okay, if I don't know, I'll do 50-50. So then you say, okay, so what about all cyclophines being a subset of the arborites? Or what about cyclophines and arborites being disjoint? Or, you know, with all four combinations possible? What about meta-arbordite being pseudo-cyclophines? I mean, we can't assign 0.5 to all of this, and I can come up with words as much as I wish, right? So the point is that, to me, it seems that we just feel, I don't know. And the Bayesian approach doesn't allow us to say, I do not know. It doesn't have in its language the term, I don't have the foggiest idea. Okay, it's not in the language. So if it's, I want to say, I don't have the foggiest idea, the Bayesian approach says, do you not have the foggiest idea 0.74 or 0.75? How much do you not have the foggiest idea? And simply not know is not in the language. Okay? And this, I think, is the main difficulty with the Bayesian approach. And then, you know, we can think about things that are a little bit more realistic. So, you know, if I think about a coin coming up head or not, we can discuss what's the probability of that, and we can think about relative frequencies and maybe symmetry, even though this is also, why would symmetry give you 50-50 is also a very interesting and deep issue, which I believe it's not. I think that what really convinces us that 50-50 is a good story is basically a theorem by Poincaré, that was dug up by Marc Machina. So Poincaré in 1907 has a theorem about the roulette wheel, and is saying basically just because it flips a lot. So it's a little bit like, you know, betting on the last digit of the Dow Jones or something like that, whether it's odd or even. Then for a large set of beliefs, you would converge to 50-50. And I think this is what happens with the coin. But, you know, sometimes we have relative frequencies. Then sometimes it's not so easy because cases become different from each other in a meaningful way. And when we talk about wars and even financial crisis and things like this, then I'm not sure that any of the standard methods applies. To say that this is not completely theoretical, so arborites and cyclophines are wonderful, right? But I mean, they don't seem terribly relevant to real life. So these are estimates of climate change that's going to happen. Basically, what we see here is the distribution. I don't remember which time frame we're talking about, but there was a paper like this that was published by Hill and Milner in 2014, actually citing some data from Science. So there are, you know, 20-some groups over the world that are trying to estimate climate change by running simulations, and this is computationally very complex. And it turns out that when you start doing the model, when dividing the oceans and the atmosphere into little beans and trying to run this simulation 20 years ahead, many small modeling decisions can change your estimates. So this is sort of meta-analysis, and this is something that Sven Kron was a master student that just completed his master at HSE this year, and he did sort of meta-analysis on something more recent because, you know, the thing I had before was about 2014, and the point is that they vary. Okay, And now we're talking about things that are more or less, given a certain human involvement. So we're not trying to predict social trends or anything like that. Just the basic physics, and these are done by real scientists. By real scientists, I mean natural scientists. They all believe in the same physics. Okay, they all believe in laws of basic laws of physics. Nothing too sophisticated here. None of them is a climate denier as far as I can see. You can see all these distributions are up here. So then this is overall average warm increase in average temperature around the globe. So the numbers are pretty high in some places, but still they vary. And my point is that, yes, I mean, if these are groups of scientists are doing now, what would be the rational thing to say, to give, equal probability to all of these and put them together? I mean, it's not clear that I want politicians to just, take some subjective hunch over these, because what science has to say, what we can objectively prove, is often not sufficiently specified to have a unique probability. So that's the basic point. So I can try to argue on this on philosophical grounds, but I think it also matters. It matters to some decisions that we have to make right now. So, before we go on to other alternatives and the newer paper, I want to say, I mean, there is something that sort of is nagging, and this is how come such a beautiful theorem leads us to something that seems a little bit incongruous. And we've written a couple of papers on this, mostly with David Schmeiler and Andy Postlewaite, and some with Larry Samuelson and Stefania. If I were to find one culprit for this, I think it's the definition of the state. So when we talk about Savage, and we give an example of an urn in which you pull out balls from this, and you do the Ellsberg experiments, and you think about urns and balls, then what the state of the world is very natural. Okay? And as I mentioned earlier, that I don't think a rational choice something is a concrete theory, because we don't really know what is a state. Just like in game theory, we can analyze the same situation without, you have to define who's the player, who's the, and what's the time frame, and things like that. So what is a state is not given by the theory. There are situations, like if I give you an urn with balls, where it's going to be only one mapping from the theory to real-life objects really makes sense. These are the balls I'm going to draw out of the states. Now, don't tell me about, little green people coming down from Mars or something like this. This would allow you to explain everything if you like, but it's pretty clear what it is.
I think it's not clear, even in this case, because the state could be the ball that will be drawn from the urn, or the state could be the composition of the urn.
Right. But then you're right in this, and there are models to do both. But at least, yeah. I mean, in both of them, I could sort of agree with this. I mean, the reason I mentioned little green people is to say that if you push this to an extreme, no experiment can violate, say, Savage's axioms, because like, whatever you had people doing the experiment, I could say, well, they had in their mind this state of the world in which if they do something else, they're being kidnapped by little green people from Mars. So the question is not whether the theory was refuted, but how many little green people you have to assume in order to salvage it. And again, Amos used to say, theories are not refuted, theories are embarrassed. And I think this is part of it, because what happened partly in economic theory is that moving from general equilibrium to game theory, we have yet much more flexibility. Even in standard general equilibrium theory, we can teach, talk about what is a product, what is a good. We can talk about tomatoes and cucumbers, and then we say, okay, let's add time periods here, let's add uncertainty here, etc. So we play around with the notion of what is a good in a model. But when we go into models of decision theory and game theory, there's much more flexibility of deciding who are the players, what are the strategies, and so on. So in particular here, there is a notion of the state. In some cases, it's going to be embarrassing to say that the state is something else, but in other cases, it's not. And in this paper with Larry Samuelson and Stefania Minardi, we count 5 different generalizations that the notion of the states has undergone in the past, let's say, 70 years, each of which is enough to undermine Savage. Okay? So one of them is the introduction of time periods, where the state now becomes your nature's strategy in the dynamic game, which, if push it to an extreme, makes nothing observable because we only observe one path, as in Milan Kundera's unbearable lightness of being. We only observe one path of history. We have something which was extremely important, was Harsanyi's idea that to say, okay, the state is going to include who we are. So he basically took us back before we were born. And the way it was described to me by David Schmeidler at the time, said this was what allowed the major breakthrough of game theory into economic theory, because David used to say that in the 60s, economists used to say, oh, game theory is very nice, but in real life, we don't know what the utilities are, so it's not useful. And then came these papers in 67, 68 that basically opened the way for. So Harsanyi did this step and allows the state also to say, who am I to be born, which model am I going to, which person I'm going to be born into. And of course, assuming evasion prior, but this entity that I was before I was born wasn't really making decisions in the Savage model, right? But Savage was assumed automatically. Aumann made some extra steps by assuming that the state of the world describes all the information partitions and everything that everyone knows in common. Okay. So there are several, and then there's Newcomb's paradox, okay, that allows for various causal relationship that says that actually a state is not, I don't know, I mean, so that if the Newcomb paradox is familiar, it's something that comes from physics. The original Newcomb's paradox is about an omniscient observer, which is not something I think I can understand or relate to. But the basic idea is that something that looks to you like a state might depend on your choice. So there might be a box that may or may not contain $1 million, and that's the way the story is told. And at the end of the story, you say, well, maybe whether it's there or not depends on what I do. So maybe I'm being rewarded for being modest, and I'm being punished for being greedy. And whether the $1 million are there or not depends on my choice. But if you take this seriously, then you don't start with states, but rather you define the states as all the possible functions from your acts to outcomes to allow for all possible causal relationships. But if you do this, then again, you can do Savage. Because in this case, you generate a state space that is by 2 orders of magnitude larger than the acts that you start out with. Okay? Because you start with the acts, then you generate the states as all the functions from acts to outcomes, and then you have the conceivable acts, which are all the functions from that state back to outcomes. So it's, by definition, much larger than what you could actually observe. And again, I want to say there's nothing about cognitive limitations in what I'm saying here. There's nothing about bounded rationality in that. If you want to be able to deal with Newcomb's paradox, you have to allow for all this, you construct the state space this way, then by definition, what you observe is a tiny fraction of the acts you want to compare. In any way, yeah.
When you say how we can reconcile this, you mean the simplicity of the Savage axioms and
not only simply how compelling they are and the.
How compelling? Well, there is an elephant in the room. That's the assumption of completeness. The fact that we had no idea about whether one state is more likely than the other is buried in the completeness assumption of Savage. The preference is complete.
Well, yes and no, because I would say, okay, at the end of the day, you have to make a decision. And if I leave the preference incomplete, I don't know what decision you're going to make. So let's write down the decision you're going to make. I know it's going to be difficult. I know you're going to be shrugging your shoulders. I know that, I don't know, maybe you'll come a decision to you in the morning when you're jogging. I don't know what. But let's.
Mean that you have a complete preference?
No. I'm not going to leave your office until you give me a complete choice. If you are the politician.
So I randomize, so I flip a coin.
So let's put in Anscombe Bauman model, you could randomize a flip a coin. Okay? You could have this, and you could make flipping a coin to be strictly better than either of the choices. It would violate some axiom of independence, but I can state it. But I don't want to let you off the hook. I mean, I'm not going to leave your office until you tell me what you do in each one of these cases, because otherwise, I mean, what I want you to think about a scenario in which I, as a decision theorist, I'm representing the public. You are the politician. You're going to make decisions for us, whether it's public, global warming or something like that. I don't want to let you make a decision after I left, because who knows what decision you're going to make. I want this decision to be written down. Okay? So in an ideal world, I mean, I have this vision of changing the world, and etc. But if in an ideal world, I would make politicians write down, just like take minutes of their decisions, write down a decision theoretic model that supports their decision. So on your way out, sit down with a decision theorist and let's write down the simplest decision theoretic model that supports the decision you made. What states you have in mind, what probability you had in mind, what was your utility. I want this to be on file. Okay? This is, in an ideal world, for me, this is what I'd expect politicians to do. Okay? So I know I can't do this, so this is why I'm talking about it here. Otherwise, I would have done it. But I would like this, I think this would be a better world, more transparent world. And if you tell me, oh, my relation is incomplete and therefore I'll do whatever I feel like, I say, well, you know, we have countries in which this is what happens, but in a democracy, I want to see it.
Let me pose the question
Yeah.
somewhat different way. I mean, the problem, the answer I don't have an idea could come out even when the states are very clear, like in the climate change. The climate change
Yeah.
is a state. We're talking about what would be the rise in the temperature, right? Still, we don't, you know, we have different assessment. We don't have an idea. So.
Tell me how you deal with not having an idea.
What I don't completely follow is your claim that the problem is with the definition of the state. My intuition
No.
would be simply that there's no, the preference is really incomplete.
Incomplete, but something
You
would
can force
happen.
me to make a decision, but
Yeah,
it really
but
does not.
reality forces, not me. Reality makes it, not making a decision is making a decision. Like, if we do nothing about climate change, that's one of the choices we can make. We could shrug our shoulders and say, look, there's no evidence, let's do nothing. And some other people would say, look, this is too risky because, you know, maybe we should do something and not do anything. But not doing anything is, you know, as we say in basic classes, not doing anything is one of the options.
I don't
And
want
if
to take
that's what
too
it-
much time.
okay.
You don't present it
Okay.
as though there is a certain paradox in the sense, a certain gap that we
Yeah.
don't understand between the simplicity of the savage axioms and the fact that in many situations, yes, we
Yeah.
don't have those. It seems to me that this, the culprit is the assumption of completeness, or one of the culprits.
I'm willing to accept it to some degree. This is where you have the two notions of rationality. So objective rationality is typically incomplete, but I do want to see the subjective rationality because you're going to do something. Now, if it's your money, okay, do whatever, I don't mind. But if you're running my public policy and you're going to make decisions that affect my children, I want to know what you're going to do. If it's nothing, let's write down you decided to do nothing, whether it's about climate change, whether it's about war, whether it's about financial things. I want to see what you're going to do. As long, let's say, think of you as an elected politician. I think you owe me to tell me what you're going to do and not just say this is incomplete and I'll do whatever I feel like. Anyway. So what I want to say that let's assume that it is complete and something that looks extremely beautiful, you know, when we see the states there. And by the way, a lot of experiments are also, you know, along the lines of Ellsberg are focusing on urns, etc. But David Schmeidler used to say, real life is not about urns and balls. And I think what he meant by this is that, you know, in real life you don't see the state space, and you often have to generate the state space as all the possible reactions of the environment to your choices, strategies of other players, etc. And in some cases, the violation a la Ellsberg are not even observable. Okay? So even in this very simple case, if I just take, let's say, you know, two options, suppose, you know, President Bush in 2008 has to decide whether to save Lehman Brothers or not. So you have two actions, save or not save, and then there are two outcomes, crisis, not crisis, crisis, not crisis. A state of the world has to specify what happens whatever you do. Okay, so you have four states of the world. But because you choose, so you're not going to observe the state, because you either choose this partition, so you see if it's 1, 2, or 3, 4, or that partition, when it's going to be 1, 3, or 2, 4. You'll never even get to observe one state. Okay, your own choice makes it. And this is going back to Kundera's unbearable lightness of being. Many of the governmental decisions people make are like this. Okay, whether it's about war, financial crisis, pandemics, or global change. We won't have a chance to rerun history to see what else is going on. And sometimes the violations of P2 along the lines of Ellsberg experiment are on an event that is not measurable in either of these partitions. Okay, so my choice would determine the partition. And okay, I'm rushing here, but I have a concrete example in one of these papers. So I can choose this partition or that partition, and I violate Ellsberg on this partition, which is completely theoretical, something that will never get to be observed. So at some point I'd say, you know what, okay, so maybe I'm willing to live up with not satisfying this on some hypothetical set of acts that I could have had, but it's not the act that I do have. Okay, try to move on to something new. So what do we do about this? There are a couple of models, and David Schneider was the pioneer of suggesting non-additive probabilities. That was the first axiomatically based model that was non-Bayesian, derived the utility function and a non-additive probability or capacity. All the rest is the same as in Anscombe-Baumann, but allowing for non-Bayesian approach. There are other things, so I'm not going to explain the Choquet integral because it's a little bit longer to explain. Something that's easier to explain is to say, let's say we have a set of probabilities and you compute expected utility relative to each one of them and take the minimum. And a set of probabilities also goes back to confidence intervals, confidence sets, okay, so it's like what we tend to have. There are a bunch of other models, so in particular the smooth preferences where you take expected utility relative to each probability and you weight by some second order probability over the probabilities, but not in a linear way, because if you have probability over probability, and it just boils down to probability. But to do something non-linear, then you get something that's not necessarily Bayesian. There are variational preferences, and there's incomplete preferences out of Bewley with a set of priors. What I'd like to talk about a little bit now is where probabilities are coming from. So with David Schneider, we devoted some time and some models to this, and some of the results would feature here. The new part I want to talk about now is this work with Stefania Minardi and Fan Wang, in which we're trying to support the idea that there are a bunch of theories, and I'm supposed to select a theory. And basically, we're going to do it by likelihood region, basically going over the likelihood function and taking something that is monotone in that. So what is monotonicity with respect to the likelihood function? We'd have a certain database. There's a bunch of distributions F. And I'm assuming that you are selecting a subset of distributions. So the basic mindset would be here to say that you have certain probabilities that you're going to work with. Now, what exactly you do with this, I'm not going to specify, so it's even okay with Elchanan's being incomplete. But I assume that you have to make decisions relative to a certain set, and the question now is which set of probabilities to choose. So CDF is a subset of F, depending on the database D. And the mindset is that we're still going to have more data coming in. So I don't have to select one single theory. I am allowing a bunch of theories and hoping that this set would converge. So it's going to be monotone if it's monotone in the likelihood function. So implicitly, I want you to think of all these functions as equally complex so that there's no reason to compare them on any other grounds apart from likelihood. So, yeah, sorry. Yeah.
It's too fast. It goes too fast.
Yeah, okay. So what I'm saying is that if your likelihood, this is, so if you chose the theory G, and the likelihood of F is at least as high as G, you should choose F as well.
That's your assumption, or
that's a sort of meta assumption. So I mean, actually no, I'm going to derive it later on. I'm first describing what are likelihood regions, and then I'm going to have something else that's called monotonicity that will help me derive it. So basically what we can, I mean the term I think the common in statistics is likelihood regions, and this is to say the upper part of some likelihood function. We could have a strict or weak version, and unfortunately this is going to be a weak point of the axiomatization, so we'll have both. I will not be able to give you necessarily one of them. So basically this, we want to think about something like this, that there is a bunch of distributions, and you take all those that are at least gamma of the max likelihood. And max could be soup, so we put here soup because we're not sure it's going to be max. And it's going to come in these two versions, okay? And then thinking about this, you take the log and you realize that what you're talking about is the epsilon maximizers, right? I mean, the idea of taking the epsilon maximizer is something that we see a lot in game theory, epsilon optimization, or something like this. And it relates to also what we're going to call to semi-orders we're going to talk about. So basically what we're going to have here is something, what we want to axiomatize or to deal with is this. So it's going to be a choice function, but it's going to depend both, I'm sorry, this is for the axiomatizations we do this, we assume that I don't only observe your choice out of the entire set of distributions, but as in choice theory out of every subset, okay? This is just to help me axiomatize this, I need more data. So I want this to be defined now for all the databases that you might be confronted with and all the subsets. And I assume that you have some non-empty choice. What I want to derive from the axioms is a statistical model. So I want to ask, when, given these kind of choice functions, when can I think of you as doing this maximum sort of upper echelon likelihood relative to some statistical model. So this is a statistical model that I don't observe. I want to derive it from your choices. When is there a probability of every observation given every possible f, such that, given a database, I compute the likelihood function, and your choices are actually of this type. And this would come in two flavors, one in which the gamma depends on the A and the D, so for a given database, different set A, you might have a different threshold gamma, and there will be one where the gamma is independent. But I have to be honest and say that in both cases I can only say something clear on the strict inequalities, and the case of equality can fall either here or there, and we don't have any axiom that implies that it's always on one side. Okay. So that's basically what we're trying to do. Okay? We're trying to do something which makes a lot of sense and has an official title in statistics, which is likelihood regions, and to support it with an axiomatic foundations. You might wonder why we do this, apart from the fact that we like to do axiomatics, so that's the only thing we know how to do. The answer is to say, well, we're looking at statistics and various types of decision-making rules there. Some of them make more sense than others, and in general in statistics the mindset is asymptotic, so that there are many things that converge nicely at the end. But when we don't have enough data, we can't wait for asymptotics. We want to see that the kind of decisions we make are sort of coherent. And we played with various things. So maximum likelihood is nice. I'll mention it later on where it popped up very nicely. But some things that we do in hypothesis testing are not so well behaved. Okay? So we try to look at some axiomatizations of this, and they're not always behave in a nice way. So the general thing is to say, okay, which of the statistical techniques are more coherent? And another reason to do it is to say, sometimes we don't have these statistical models. So when I talk about the climate change thing and I go to these groups of geophysicists who run this thing, they know, they can give me the F and they can tell me exactly what they do, and maybe they don't need me so much, maybe this is what they do anyway. But when I talk about political experts and I ask them about the war in Ukraine, then typically they don't have a well-defined F, and maybe if I can be convinced by the axioms, then I'll say, okay, maybe it's a good idea to think in terms of some probabilistic model. You have many different distributions now are allowed, and pick up the upper echelon of the likelihood function. So I'll pick up the pace a little bit. So we call this a quasi-representation because I'm not saying what happens in equality. Okay, so this is a weakness of this result I'm going to present. So in the finite case, or I mean, maybe more generally, I can think about just take the log. So this is like take all the f's or distributions f whose quality utility function is at least as high as, very close to the max, up to some delta. And this relates to the notion of semi-orders and just noticeable differences. So this is something that was nice to me because it's something I worked on at the time when I was a student. Weber has this thing about our imperfect ability to perceive things. Often it's called Weber-Fechner law, but after talking to an expert, I realized that what we need is just Weber law. And Weber says that the change in the stimuli relative to the stimulus is constant. So they define the minimal change in the stimulus by some probabilistic way. Let's say I have to compare two weights, and the question is, when will I notice that the heavier object is truly heavier with probability 75%? 75% is sort of the standard in these experiments. And it turns out that what Weber suggested in 1834 still works as a very good approximation to this day. and this is proportionality. That if you have S versus delta S have to be proportional. Fechner did something else about subjective feeling in the 1850s, 58, and this was changed in the 1970s. There's a better law that, but just in terms of perception, it's still considered to be the best first approximation. Duncan Lewis used this to develop a theory of decision making and saying basically, look, if you cannot compare things perfectly, then how could we assume transitivity of indifference? The famous example of you take a coffee cup and you put in 1 grain of sugar and you cannot tell the difference between 2 consecutive cups, so you cannot have transitivity of indifference. I'm not sure it makes a huge difference to the way we do economic theory. There's some work about how you do general equilibrium with these and the welfare theorems with the semi-ordered preferences. I do think it makes a huge difference in terms of the ordinality of the utility function. So I think that the fact that we say that the utility function in consumer theory is only ordinal and that there is no meaning to differences to comparing differences is really a myth, because we take this transitive indifference seriously. And it's just a mathematical model. It's an okay mathematical model for many purposes, but it throws away a lot of information, and actually the just noticeable difference that Weber talked about give us some very natural way to compare differences and can give meaning to decreasing marginal utility when I'm thinking about it. And it can even, in the paper with Rossella Argenziano, we argue that it can even make sense to interpersonal comparisons of utility. Okay? Like how many just noticeable differences would you lose and how many would I gain? And people take issue with this and we don't think it's perfect, but something that is generally considered to be completely nonsensical in economic theory, how could you possibly compare utility of different people, get some meaning, and we argue that in some cases it actually makes sense. In any event, these semi-orders have been around, and they had to do, in this case, in imperfect perception. Now we're talking about the same structure, not because of imperfect perception, but because of I, as a scientist, know that the more data are going to be there. I don't want to throw away theories that might tomorrow be the maximum likelihood, the likelihood maximizers. I'll skip that. There are also interval orders, but I'll skip them. People have been looking at axiomatizing this. So the first part of the paper, and I will not tell you why what we do is still necessary and to what extent we add, but the first part of the paper is just to forget about the databases and just to say under which conditions you have a choice function that takes subsets from sets. Can we think of it as a selecting something, the upper echelon of some semi-order? We retain sense alpha, sense beta is inappropriate. We have an axiom called union that says that if F is selected of A and G out of B, then either F or G, one of them should be selected out of both. Continuity is a bit technical, only for the infinite case. We'll skip this. And we have monotonicity. And monotonicity says if there is evidence that F is better than G, which could be one of two, and we need both. One is that F is selected out of a set and G isn't. Or an indirect one, when you take a B that doesn't contain them, neither F or G are in B. But when you add G, Z remains there. When you add F, Z is dropped. So there's some indirect evidence that F is better than G. Then in both cases we say that F is preferred to G. And the extra assumption that we need is that your set is monotone relative to this relation. Namely, if F is above G and G is selected, then so is F. And this is basically what we need to say that the choice function can be described by this semi-order. So I didn't really define what the semi-order is, but the axioms are given by Lewis, but we can think of it as something that is of this nature. So in a finite model, we get what we want. Sorry, I'm running out of time. So let me just say that what we do in the second part of the paper is take this thing and merge it with the databases. So now the question is, how do these selections, so that out of every for every given database, I'm selecting something that looks like the top part of some semi-order. Now I have the databases, and I'm allowing this to, so a database is just a counter vector. It's a selection saying how many times I've seen each one of these observations, and I'm thinking about finite databases. I can describe operations on them. There are a bunch of axioms I won't carry you through because these are basically axioms that David and I used in a different setup, and this would give you just maximum likelihood. So if you have a binary relation that satisfy these things, then you basically, I can think of you as if you have a probabilistic model in mind and you're selecting a binary relation. So this gives us some result, but the interesting part is to merge them, and this is what we do here, and I have to conclude. The way the interesting merge is to say, okay, suppose that we take any two databases. If one of them makes me feel that F is strictly above G in this semi-order sense, so that I don't, if F is there, I'm dropping G. I'm not taking G if I have F in my set. Okay, the difference between them is large enough to cross G out. The other one says that F is at least as good as G, but maybe both of them can coexist. Then when I merge the two databases, then again I can cross G out. And the converse part is about the same. If you don't have a reason to prefer F, and actually G is better than F in a new database, then certainly you would not throw out G. This and a couple of technical axioms and richness, etc., give us the main result, which is what we wanted, namely, so if you satisfy these 8 axioms, I know it's a lot, but so 4 of them are for, even more. One of them says that, for every given database you satisfy the previous axioms we had, and then there are some axioms about how you behave with different databases. I can think of you as if you have a probabilistic model, a statistical model in mind, namely, if I can assign a probability number for every F. In the model, by the way, F is completely abstract, okay, so there's no statistics to begin with. F is just a set of symbols, and the same is X. But if you behave in a way that satisfies the axiom, I can think of you as if you, for every F, you have a certain probability for each X, and a single constant gamma such that, this is the likelihood function now, okay, so given a database, we just, assuming independence implicitly, so we just multiply these probability numbers in the database. And it turns out that whenever something is above the gamma of the soup, you take it. If it's below, you don't take it. And I'm not saying anything what happens about if it's equal. But to me, it would try to say that this means that there is some probabilistic statistical model in mind such that what you're doing is being coherent with the likelihood function. So basically, it's supposed to say something about, where do we get the probabilities from? So suppose there are many theories out there in the world. Something very natural like maximum likelihood or top likelihood region makes sense also in terms of axioms. And there are many other things that should be included, in particular allowing theories to differentiate among theories depending on their complexity, and to think about vague theories, etc. So we'll stop here because of my time.